Andrew Bochman is a senior grid strategist at Idaho National Laboratory. John Cusimano is the VP of Industrial Cybersecurity at AE Solutions. Both gentlemen have been focusing on understanding and reducing the consequence side of the risk equation. Please welcome Andy, John, and Dale to the S4 main stage.
Thanks, guys.
Good morning, everyone. So I think we are going to definitely miss Ms. Manfra here. Unfortunately, she couldn't make the keynote because of the government shutdown and DHS being affected quite a bit. But I think we have a really great keynote block for you this morning. We're going to start out with a talk about consequence and consequence-focused risk reduction, let's say methodologies or projects. And it's kind of interesting because if you look at the risk equation, simplified version, risk is likelihood times consequence. And as security professionals, we almost exclusively focus on security controls that will reduce likelihood. But again, consequence is part of that equation, so maybe we should be looking more at consequence, and these two gentlemen have been doing that with two different approaches. So we're going to give them each a chance to introduce their approach, and then we're going to talk about where they differ and maybe ask some other interesting questions about it. So we decided John would start with his CyberPHA. So if we could put up John's slide on the confidence monitor as well. And John, please, go ahead.
Okay. Well, good morning, everybody. My name is John Cusimano, and the CyberPHA methodology is something that was kind of born in the early 20-teens. It was like somewhere between 2010 and 2012 time period, and it was a collaborative effort with standards bodies like ISA, and also with some clients, asset owners that were very interested in bringing a level of engineering discipline into ICS cybersecurity risk assessments in particular, and leveraging the information we already had or the processes we already had around process safety and functional safety, and bringing some of that engineering discipline into cybersecurity. So that's why the term CyberPHA was coined, to make kind of that reference to the process hazard analysis, PHA, methodology that's already well known, particularly in the process industries, and make that connection between how do we assess the consequences that could be caused by cyber? How do we decide of those consequences that we already know could happen to an industrial process through those engineering efforts? How do we figure out which ones could be caused by cyber, and then drill down deeper into how could that happen? So the methodology has been around for many years now, in practice for about 5 years. It's based on standards, and it's based on the safety discipline, bringing some of that discipline into the process. And it's multifunctional, so one of the key things about it, and part of that diagram shows the idea of no one person in a facility is going to understand all of the potential threats, vulnerabilities, and particularly the consequences. So it takes a team of bringing together both automation professionals and IT professionals and operations professionals together to talk about the problem and to understand those risks. Down at the bottom, I show the process there, and it basically starts with, first you have to understand the system that you're going to be assessing. So the first leftmost block talks about documenting the existing system in terms of having a good architecture diagram of what the system really looks like. I like to do it in a Purdue model. I guess I'm a little old-fashioned because I heard Purdue is dead, but not in my world. So we still use the Purdue model as a nice way to organize the information. And then from there, it moves into a vulnerability assessment. So again, before you can understand risk, you have to understand the three main variables of risk, security risk, which are threats, vulnerabilities, and consequences. So very important to understand the potential vulnerabilities in the system, and that's what a vulnerability assessment would be performed. And then the system is partitioned into typically into zones, security zones and conduits, following the ISA 62443 model. And then really the heart of the process is that fourth block over, the actual risk assessment workshop, where a cross-functional team led by a facilitator looks at each security zone, or each zone, and talks about what are the realistic threats, what are the known vulnerabilities, and most importantly, the consequences. Actually, and I stated a little bit backwards because it starts with the consequence. We usually work left to right and identify the consequences, the worst case consequences that could be caused by a cyber incident, by a cyber initiating event or compromise of a safety function, and then talk about how could that happen, what would be the causes, and those are typically the threats, the threat sources, the threat actors, the vulnerabilities that those threats might try to exploit. And that provides a pretty nice picture of a potential threat scenario. You might also call it the kill chain. How could somebody attack this system to result in this consequence? And working through those discussions, we talk about a grounded discussion and how could that happen, and then try to put some metrics around that, typically using the client's risk matrix. So we will eventually, you're getting down to assessing what is the likelihood and what is the consequence, and subsequently then what is the risk.
Okay, thank you. So that's one approach, and then Idaho National Labs has been working on a different approach called CCE. I'll let you define it so I don't get it wrong. But Andy, why don't you tell them about your procedure? I think you can move to your slide there if you use your clicker.
Okay, let's check that out. Okay, great. I think, Dale, you said we could stand a little bit if we needed to.
You can stroll if you like.
I have a gesture, and then I'll sit back down after I
stay in the light.
The gesture. Okay, hi, everybody. We're talking about this entire methodology, which is still, in a sense, a baby methodology. It's been going through several pilots. It'll have some more before it becomes ready for prime time. The people at Idaho are heads down working on this with support from DOE, DHS, and DOD, and others. But the gesture that I was referring to is like this. I couldn't do it on the podcast with Dale. You wouldn't have seen it. When you're charged with protecting a large industrial enterprise or a significant DOD organization, the number of things that we have to protect from endpoints and networks and people and processes is the entire enterprise, right? We don't generally treat some things markedly different than others because there's different pathways around. So you're charged, and the CSO is charged with protecting the whole thing. CCE, this compound acronym, consequence-driven cyber-informed engineering, is not about protecting the whole thing. You need to continue protecting everything to the best of your ability using best practices, using the best tools, using what you can find at RSA and elsewhere. But CCE in the first phase, which I'll unpack really quickly so we can get interactive, is about identifying these things, the handful of processes and functions that simply must not fail. These things are so important that to lose them, to be without them for more than a day or two, is a company-ending event. So it's about strategic business risk, it's about corporate viability for the military, it's about mission risk. And that's the intention, that's the primary mover of this whole thing. When we go back and forth, we'll talk a little bit about likelihood, but that's really not it. That's partially what makes this methodology a little bit different. I'll step you through the things quickly. Before I hit the button, let me just say, this looks like an assessment, looks like an approach for doing an assessment, but it's not. That's not its real intent. The lines below the main title there suggest and are trying to communicate. It's really about trying to change the minds, trying to change the way senior leaders and engineers and operators think about cyber risk, so that it's enduring after the assessment, which is really OJT and done arm in arm. It's not done to you, it's done with you. That the lessons learned from that process stay with that company, stay with that organization, and are inculcated throughout all different levels of personnel. So I'll do this, like I said, pretty quickly. The first step, we don't even say the word cyber, doesn't come into it. It's about identifying the crown jewels, if you will, the holiest of holies, the things that I said when my arms went like this, that simply must not fail. People need a way, because it's all about prioritization. need a way of making that happen. So the HCE score is the high consequence event score, and it's informed by those factors that ring around it. And that itself is a work in progress, fine-tuning the different weighting and fine-tuning the elements that contribute to an HCE score, so you can rack and stack what you're going to work on first, the things that are the absolutely most important. System of system breakdown in Quad 2 is about identifying the whole ecosystem, all the hardware, software, processes, networks, comms, and people, and supply chain, and all that stuff that support those things that must not fail. You need to know that because the adversary goes to school on that. You need to know it at least as well as they do. The step 3 is consequence-based targeting. This is where we team with the Intel community and identify, now that we know the things that must not fail, what are the ways many of my adversary-experienced colleagues at INL, we put that hat on and go after these things. And along the way, the owners of the company or the organization and the engineers and the operators, they see that there are in fact ways to go in, even when it's things that they thought initially, it's really important to us, but it could never happen. We show them it could happen, and that's part of the conversion process. And then finally is mitigations and protections. We can talk more about that later, but some of them are counterintuitive. Some of them the press pick up and twist a little bit in ways that are not completely accurate. This is where we start talking about the potential of considering out-of-band solutions, sometimes analog technology, sometimes bringing trusted humans back in the loop who were replaced because of automation and efficiency and saving money in the past. So I'll leave off there.
Okay, great. So we've got two different approaches, both consequence-focused risk management. I guess one of the things I'd first like to start out with is, John, do you see any, obviously there's a lot of similarities, do you see any differences worth noting to the audience between the two approaches?
Sure. There are probably more similarities than there are differences. They're both consequence-driven. They're both cyber-informed processes. And they both even talk about partitioning the system into more manageable, accessible entities. Probably the biggest difference is really that the CyberPHA methodology is based on safety engineering principles and practices, and it's based on industry standards, such as particularly 62443. A lot of the derivation of this of this methodology will be documented in 62443-3-2. It's been approved, but it has not yet been published.
Okay.
So a lot of the framework of the process is in that document. So it's based on IEC standards, as well as there's a technical report from the S84 committee that also talks about a very similar methodology. So the main difference, I would say, is that PHA is based on these safety engineering principles and industry standards.
Okay. Yeah. How about from your side?
I think two primary things, Dale. One is, and I alluded to, I think both of them in that opening salvo. One is the adversarial orientation, experience, point of view of the core teams that are driving the engagement, the CCE engagement. I think in many cases the asset owners have never really seen, they've seen defense from the inside looking out, but they haven't seen the whole thing turned around and what they look like from outside. When they get to see what their own organization, what their systems, what their defenses look like from the outside and see some of the gaps and how porous parts of it are, even with very good hygiene, even with an excellent chief security officer, even complying with all relevant standards, when they get to see the different ways adversaries will target, and some ways that really surprise them, that they never thought of, certainly that the engineers didn't see coming, that really motivates them to take a different approach, or to at least consider following this and having their minds start to change. Second part is the pairing in quadrant 3 with the Intel community. That's where I think we would touch on. It'll seem like it's all consequence, but it gives you a little bit of likelihood that helps with prioritization. When somebody in the Intel community is able to inform the process and say, this system that's like really important to you, well, it depends on these products, and these products we've noticed have been purchased by country A or APT B. and they're doing things with them that clearly aren't, they're not using them the way they were intended. It's them being aware, the CEO being aware of that, really changes their feeling about the gravity of this and the urgency of taking some different steps.
Okay, one of the things, and Andy and I had a podcast, let me get to this.
Good.
So we had a podcast, and so he and I I've already asked him a bunch of questions, but the one issue that I think is still kind of lingering in my mind is, and it ties back to how I started S4, I see the world just moving faster and faster, and we don't have as much time to implement any approach,
Sure.
whether it be consequence or likelihood or whatever you want to say. And when I look at what I put up there, the CCE, I see in step 1 we say these are the really terrible things that we can't allow to happen. And then in step 4 we say here's how we prevent, no matter what, these really terrible things from happening. Why do I bother with probably the most time-consuming steps of 2 and 3? Couldn't I get almost all the advantages just by doing steps 1 and 4?
That was beautifully stated.
Thank you.
Yeah. This was a point in the podcast, and we'll keep doing it to hopefully help have people better understand this. I think the main reason why those 2 steps are there, and we'll see, it is flexible. It's still being developed, so it's possible your feedback and others will influence the final shape this thing takes or the evolving shape of it. But the main point is that the line below the title, we're not trying to do a one-time assessment. We're trying to lead them through a process that really opens their eyes and wakes them up. That's one thing. They need to see what they look like, both from their whole lay of the land in step 2, the system of systems breakdown, and they really need to see what they look like through the eyes of the adversary. So that's the part where it's not us being a service provider doing it to them, that's us arm in arm with them, showing it to them that way. The second part of the answer, and I'll keep this brief, is from a national security point of view, in this case, not necessarily just the individual owners and owners of the assets in the company on the one-on-one engagement, but from a national point of view, we need to go the extra mile. We can't identify 80% of the things and lock those down and feel good about it. Reducing 80% of the primary risks to the holiest of holies is a great thing. No one would argue with that, right? But for certain companies that support certain national critical missions, that's not enough. They really need to go the last step. And things emerge in those, especially step 3, things emerge there that you didn't even see coming in the previous steps.
Yeah, I could see how there's some value in that, for an overall program.
Yeah.
And then it's just a question of how necessary is it to achieve the goal. John, I wanted to ask you kind of a same resource question because, again, everyone's resource strapped.
Right.
I was lucky enough to participate in one of your CyberPHAs a few years ago, and I know since then you've probably done about 100 or so of them. How many, I'm not going to ask you for a price, but about how many man-hours, if you had a trained team, whether it be internal, external, third party, about how many man-hours would it take to do something like a CyberPHA?
Sure. So the process that I showed on that slide talked about those 5 different steps. And typically that's going to take about somewhere in a duration of about 4 to 6 weeks end to end to complete that process. It varies a lot with the size and the complexity of the facility and then the number of systems. And it also depends on how well documented the system already is and what kind of vulnerability assessments have already been performed.
But does it assume that you already have a PHA done? Is this like an add-on to
it does assume, yeah, so it does leverage the PHA. So if a PHA exists, we're going to draw from those consequences and again, try to avoid that repeat engineering. And some industries don't do PHAs. So in that case, then those consequences have to be derived during the CyberPHA. We also add to, so it's not just, PHAs are generally going to identify health, safety, environmental consequences, but there's also product quality consequences, there's also service interruption consequences that cyber events can cause that would not be documented in a PHA. So we do go beyond that. So, but roughly about 4 to 6 weeks. And I did want to back what Andy said, though. I think the 2 middle blocks in the CCE, which are analogous to some of the partitioning that we do in phase 3, They're really important. If you try to look at, like, take a refinery, for example. If you're trying to say, we're gonna assess all of the control systems in a refinery and not break it down by unit or unit operation or system, it's almost impossible. You have to break it down into system of systems or zones and conduits, whatever you choose to call it. And you do have to understand how that system is constructed and what are the vulnerabilities to have an intelligent conversation. So those first 2 blocks for us, or actually the first 3 blocks for us, are all really the prep for the workshop. The workshop itself typically takes 3 to 5 days, depending on the size and complexity of a facility, but there's a lot of homework that has to be done, because when you get those resources together that we're talking about, they're expensive people and their time is valuable. So you want to make sure that all of that information has been prepped and that you're making the most efficient use of their time.
Okay. And when you say 4 to 6 weeks, that's elapsed time. About how many people is that? Do you have any idea in terms of weeks?
Each of those takes different resources. The first 3 are typically done by probably a 2-person team. Typically, okay. We'll do all that prep work, and of course, there's some involvement from the asset owner. Particularly if it's on site, there has to be some facilitation of getting access to those facilities and systems. The workshop is the most resource-intensive part. It is also the shortest, so as I said, 3 to 5 days. But a typical CyberPHA team is going to have representatives from automation engineering, from IT or IT security, or both. Usually an HSE representative will be participating, and operations people, who you really have to have people involved that actually know the process. And when you ask them questions like, what if your HMI screens all went blank one day? What would you do? So you do need to have operations involved too.
So when you add it all up, you might actually be close to half to a full man-year of time. You know, if you say 5 people and 5 weeks, that's 25 weeks. But I mean, we don't have to get it, but it's 4 to 6 weeks elapsed time, but there's a lot of participants and
I said particularly the workshop is the most resource intense, and that might have 5 to 10 people in the room for a week.
And then I guess just one other comment on that. So when you talk about those middle steps, I think a lot of my concern with them is based on how deep you go. You know, so if you say we're going to take 3 people for 2 weeks to get that information, I worry less than if we're trying to extensively document it, because that could be a 3-week project or a full year project for a complex system. I want to make sure we note for the audience who maybe isn't as familiar with this, Andy, what are some of the maybe atypical ways that you prevent these really bad things from happening? You know, in step 4 that you know are not ICS security controls.
I'll switch back to that.
Okay, sure.
First of all, I'd like to say a lot of what John was describing in his process is certainly familiar, and this CC is not intending to be something completely new under the sun. Many people say, oh, it reminds me of what we do with crown jewel analysis, or something that the DoD already does and PHA, and we like that. That's a head start for the people that are involved. The second point I'd just like to say is it sounds like you're educating people as you're doing this with them, to them at the same time too. Difference with CCE is, in addition to the players that you mentioned that have to be involved, all of those are part of CCE. We begin with the CEO or the 3-star general. They've got to have buy-in, because we're going to do some things to them. And we need that top-down education and support as we work our way down into senior engineering and then into the guys with the hands on the systems. Some of the novel mitigations, I think, and again, this is what, when I say these things, this is what the press picks up sometimes, and I don't necessarily mean ill-intentioned. It's mainly the headline, I think, is we're talking about using technologies that are precursors to the whole digital automated world which we find ourselves in now. The way the grid and other industries used to work, things that were more mechanical, more analog, more educated, trusted, human-based. And so the headline that's come out multiple times is, INO wants to dumb down the smart grid. And the way that that's not accurate or is misleading is that, if you remember my first gesture, we don't want to do anything to the whole smart grid and its analogs in other industries. We want to protect the things that must not fail. So it's not the whole enchilada. And the second thing is the dumbing down parts problem. I think when people hear analog, they think, oh, they want to replace computers with springs or pumps or valves. And no, the analog primarily comes in at the very end of the mitigations in phase 4. So just to give you some semi-tangible example, if you had, and you can make, I think, visuals with Stuxnet here too. If you have a generator that is all wired up, automated, and digital monitoring and digital controls on it, and it's given instruction because the adversary made it all the way to it and could push a button that will tell that thing to kill itself, a la Aurora, if you're familiar with that from INL. One of the mitigations we saw the engineers develop was simply running a tripwire, a wire that used to feed into a digital system that now allows a generator or some equivalent piece of equipment, long lead time to replace equipment, allows it to shut down gracefully, go into a safe state. Cost for such a thing after you do the engineering work is not all that significant, and it's not relying on more complex, hard to discern how effective software tools. It's a mechanical solution or an analog solution to a digital problem. All the digital stuff stays in play there. We didn't replace anything. It's just a backstop. The CEO of one of the pilots that we did, companies we did a pilot with, after he was come to understood the power of this approach, he went to Congress, and one of the lines that he said that it really stuck with me was, in the utility business, I can handle disruption. I can handle outages. We're used to it all the time, and we're prepared for it. He's like, what I can handle is destruction of long lead time to replace equipment. Mm-hmm. So again, disruption, okay, and that would be a disruption if that thing tripped. Destruction of certain things is we can't handle that stuff, and that's the intent of this.
Do you have just maybe very quickly any other odd remediations that people might not consider security controls that Andy didn't mention? If not, we'll jump to another one.
No, absolutely. So that's a really important part of the process is understanding what safeguards are already in place, whether they are cyber countermeasures or if they are mechanical or other safeguards that are built into the process. And we find that a lot. So one of the things we say is with the process is we often discover hidden risks. But the other thing we also discover is sometimes there are perceived risks that people think, oh, this must be very high risk because the potential consequence is very high. But when you look at all the different existing layers of safeguards that are in place that are non-programmable, non-networked, such as a good example that kind of goes both ways. I've seen both with tank overflow scenarios. It's in the oil and gas industry, that's always a potential that you may overfill a tank and you may have a loss of containment product on the ground that could eventually maybe catch fire. So that's always a scenario that we look at when tanks are involved. And you see a lot of different scenarios. Some cases, there's a lot of independent systems. So in addition to the basic process control system that may have level sensors, when we say, well, what if the BPCS was compromised? You got operators seeing bad levels. Well, they say, well, but we have a safeguard. We have a separate independent system with its own level switches, and we also have a process where operators go make rounds every once in a while and look at the actual level sight glasses. So those are kind of safeguards that can be in place. And another related example with a tank overflow is we had a scenario where a client had an AMS system, an asset management system for managing their field devices and transmitters. Mm-hmm. And we discovered in the vulnerability assessment that of course, the AMS system had the ability to communicate all the way from level 3 to level 0. And either accidentally or maliciously, somebody could accidentally, for example, rearrange a transmitter, bypassing the control system and safety system, rearrange a transmitter. Now you're seeing reverse levels or flows or pressures and things like that. So in that case, there was that significant vulnerability that bypassed a lot of the other safeguards. And a very simple countermeasure to that is there's most smart transmitters have a write protect jumper. If you put that jumper in place, then you cannot programmatically change those values. But if that jumper is removed, you can. So a simple safeguard is to use that write protect switch or use the run stop on a PLC.
Okay. So we're almost out of time here. Very quickly, John, do you see the CyberPHA being integrated into the PHA in the future? And if so, how long until we get there? Very quickly.
I think they're complementary processes. We actually explored the idea of trying to do them together, and it doesn't work. PHA is it's a OSHA PSM mandated process, so it really has to have some sanctity around it. And also the players, they're long and hard enough to do a PHA. To try to do cyber simultaneously is not practical. So they're better off being done in series. PHA, CyberPHA.
Okay, and Andy, if someone wants to learn more about CCE and what INL is doing, you know, I'm always pushing you to put out white papers and things. Where can they go to get the latest and greatest today?
They really can't go anywhere yet, Dale. I appreciate the way you said that. Perhaps another podcast will be in the offing. It's kind of like the core team is heads down, working on this, doing pilots, refining it. They're still baking it. And I'm causing them trouble, actually, every time I talk about it, because people are like saying, well, how do we find out more information? Do you have anything more detailed? I'll tell you this one thing. A few organizations are tired of waiting, and they, based on what they learned from the Harvard Business Review article and the podcast, they've started doing it to themselves. Okay. I imagine, from the feedback I've heard from them, they largely cut out steps 2 and 3 also, and they go right to it. They do it to themselves, and they've had some really interesting mitigations at the end of the rainbow. The last thing I'll say is, for those types of companies and others, starting to write a get started guide, something that people can use to do it to themselves, which will be part of an eventual book.
Okay, cool. Okay, well, thank you, gentlemen. Appreciate you.
Thank you.
Coming out here.
Wonderful.